Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam. Whether you're targeting a grade 7 or pushing for a 9, let's get into it.
This one fact will grab you. Examiners reported that triangle questions, the sine and cosine rule ones, cost more lost marks across the higher papers than almost any single subtopic last year. Why? Because students pick the wrong rule and then lose method marks while they try to rescue the answer. Sound familiar? Stick with me for the next 12 minutes and I'll give you a single decision routine that stops that panic every time.
Quick roadmap. First, I'll show the one decision rule you need. Then we'll derive the sine and cosine rules in plain language so you actually understand them, not just memorize formulas. Next, I'll walk you through exam technique, what the examiner is looking for, step by step. After that, a 10-second quick win you can use in any paper. Finally, a worked example and a practice prompt. Ready? Let's work through this step by step.
Okay, quick question before we start. How do I know which rule to try first when I see a triangle?
Great question. Here's the decision rule, the single routine you should run in your head in 10 seconds. List what you have. If you have two sides and the included angle between them, use the cosine rule. If you have an angle and a side opposite that angle, or two angles and a side, use the sine rule. If you have three sides, cosine rule. Write that down once and you've halved the guessing. Let that sink in.
Now, let's explain why each rule works. First, the sine rule. Picture any triangle labelled A, B, C, with opposite sides A, B, C. Drop an altitude from one vertex. The height splits the triangle and creates right-angled relationships. Using sine on those right triangles gives you expressions like A equals 2r sine A, B equals 2r sine B, C equals 2r sine C. Or, more commonly, we write A over sine A equals B over sine B equals C over sine C. In plain English, the side length is proportional to the sine of its opposite angle. That's why the sine rule is perfect when you know an angle and the side opposite it. The formula directly relates the two.
So the sine rule links sides and opposite angles. Got it. But when does that fail?
It fails in the sense it's not the tidy choice when you don't have an opposite pair. For example, if you have two sides and the included angle, that's where the cosine rule shines. Let me show you the cosine rule in a straightforward way. Put the triangle on the page with angle C between sides A and B. Drop a perpendicular from one end and use Pythagoras in the smaller right triangle. After a little algebra, you get c squared equals a squared plus b squared minus 2ab cos c. So c squared equals a squared plus b squared minus 2ab cos c. This is just Pythagoras with a correction term that involves cos c. When the angle c is 90 degrees, cos c is 0, and we return to Pythagoras, which is comforting because it shows the cosine rule generalizes Pythagoras to any angle.
Important practical point. Rearranging the cosine rule lets you find an angle when you know three sides. Rearranged, cos c is equal to a squared plus b squared minus c squared over 2ab. That formula is your go-to if the question gives three sides and asks for an angle, a common exam style.
Before we move on, always label your triangle. Write which side is opposite which angle. Examiners love to see labelling because it shows you understand which quantities match. This is an easy M1 in many mark schemes. Write it down, don't just think it.
Right, examiner speak. Let's take a typical 3-mark triangle question. The mark scheme often goes M1 for a correct equation using the appropriate rule, M1 for a correct substitution or algebraic step, A1 for the correct final answer to the required accuracy. So even if you don't finish the arithmetic, showing the correct setup can earn you a method mark. Here's the bad news. Vague statements like use trig won't get you anything. The examiner wants the formula written down, numbers substituted, and any rearrangement shown. C equals 8 without work is risky. Write the rule. Cosine rule. C squared equals A squared plus B squared minus 2AB cos C. Then substitute the numbers. That's where the marks are. Marks are there for the taking.
So if I just write down a formula and an answer, I might miss the marks.
Exactly. Write the formula first, then the substitution, then your arithmetic. If you're solving an equation for a side, show the square root step. If you're solving for an angle, show the cosine inverse step, and make sure your calculator is in degrees. Small omissions, like not showing you did cos inverse, can lose that final accuracy mark if the answer is slightly off. Read the question twice, solve it once.
Now the quick win, a 10-second decision checklist you can use on any triangle question. 1. List what you know. How many sides, how many angles, and which are opposite which. 2. If you see two sides with the angle between them, pick cosine. 3. If you see a side and its opposite angle, or two angles and a side, pick sine. 4. If three sides, cosine rule to find an angle. That's your routine. Use it before you touch the calculator.
And a rapid estimation check to catch slips. Compare side ordering and angle ordering. The largest side must be opposite the largest angle. After you compute an angle, ask, does this order make sense? Another lightning check for numerical work. If you use the cosine rule, check c squared roughly equals a squared plus b squared minus 2ab cos c. Even a coarse mental check, orders of magnitude, will catch many sign and decimal errors. Don't skip the check.
Can you walk me through a quick worked example? I like seeing the whole thing.
Absolutely. Let's be concrete. Triangle ABC. Side A equals 8, side B equals 6, angle C equals 60 degrees between them. Question, find side C, then find angle B. Step 1. We have two sides and the included angle, so cosine rule for C. Right, c squared equals a squared plus b squared minus 2ab cos c. Substitute, c squared equals 8 squared plus 6 squared minus 2 times 8 times 6 times cos 60 degrees. Compute, 64 plus 36 minus 96 times 0.5 equals 100 minus 48 equals 52, so c equals square root of 52. If you're writing this in an exam, show the square root step. C equals root 52 equals 7.21 to 3 significant figures. That's your A1 once rounding is correct.
Step 2. Find angle B. We now know side B equals 6, side A equals 8, and side C approximately 7.21. We could use cosine rule to find angle B from cos B equals a squared plus c squared minus b squared divided by 2ac, or use the sine rule because we know side and opposite angle pair. Use sine rule here since we have side A and angle A. Wait, we don't know angle A, so choose cosine to find angle B, or use sine if you prefer to use the angle opposite a known side. Let me keep it simple and use cosine rearranged. Cos B equals a squared plus c squared minus b squared divided by 2ac. Substitute the numbers. Cos B equals 64 plus 52 minus 36 divided by 2 times 8 times 7.21, approximately 80 divided by 115.36, approximately 0.693. Then B equals cos inverse of 0.693, approximately 46 degrees to the nearest degree. Write the formula, show the substitution, and the inverse cosine step, and you'll claim the marks.
Nice. The checklist worked. Cosine first, then a quick choice for angle B. Could I have used the sine rule at the end instead? You could, but only if you had a known angle to pair with a known opposite side. After the first step, you could find one angle and then use sine to find the others. Both approaches work. The key exam tip: whichever route you take, show the setup and the substitution clearly. Remember, M1 for the equation, M1 for the substitution or rearrangement, A1 for the correct answer. Write it out.
Pause the episode now and try this one. Triangle with sides 5 and 7 and angle between them 120 degrees. Find the third side. Run the 10-second checklist, decide which rule, and write the formula before calculating. I'll wait. Back? How did that feel?
It felt good, actually. The checklist made it obvious. I used cosine and got an answer that seems reasonable after checking orders of magnitude.
Perfect. That's exactly the point. Routine beats panic. Quick recap in one sentence. Use the 10-second checklist to pick sine or cosine, show your formula and substitution for method marks, then run a quick ordering check to catch arithmetic slips. That's your quick win for today.
If this helped, share it with a friend who's revising. You'll find more worked solutions and revision resources at jcacademyonline.co.uk. Until next time, trust the process and nail that exam. Stay curious.